Welcome to Justifying and Explaining Your Answers with me, Brandon. I guess we'll get started with some of the information that's pretty important for you to know, which is, first of all, our fantastic social media. You can check out some wonderful content on our TikTok, which you'll see me in. You'll see some great reminders on our Twitter and Instagram at Think5able, and our YouTube channel. We're uploading some new replays for some content that we've kind of covered in the past, like unit guides. So you might be wondering, what does justifying and explaining your answers mean? And all it means is that when you answer free response questions, you can't just give a number. You have to explain your answer and or justify it. And so today we'll start off with an update from College Board, a quick free response exam structure. We'll go through a quick review of some concepts in which you would need to justify and explain your answers. We'll go through some examples. And then finally, we'll do live practice with Nearpod. Okay, so let's go through the types of FRQs. I think I did cut out the information about what College Board told us. But basically, traditionally, what's been on free response questions is stuff like in and out questions, which is typically the first FRQ. They give you a function or rate of people or things entering and people or things leaving. You usually have to justify maxes or mins. You might have to justify whether the rate of change is increasing or decreasing. In that instance, you'd be using the second derivative. Or you'll see a question like a graph question where they'll give you the graph of a derivative or the graph of the second derivative and ask you to explain increasing or decreasing, concave up or down, points of inflection. And finally, chart questions are probably one of the last types of FRQs where you'll see you'd have to kind of give like a sentence explanation. That would be interpreting the meanings of derivatives, citing MVT, IVT, and EVT, and justifying over or under estimates. Rashika said, can we specifically go over interpreting meanings and citing theorems? Yes. And Perla there answered Nikki's question very well there. You're not expected to use your calculator, but it's good to have it handy. All right, so let's go through some reminders. So remember, we're talking about the first and second derivative here. These are pretty much like the biggest place where College Board takes off points from FRQs, because people accidentally might use the first derivative as a justification for concave up or down or points of inflection, or they'll use the second derivative for increasing or decreasing, things like that. So you should probably already have known this. This is review from your first and second semester, that when y is increasing, the first derivative is greater than 0, which is above the x-axis. If it's decreasing, it's less than 0. Mins means it goes from decreasing to increasing, or if the first derivative is equal to 0 and the second derivative is greater than 0. And then if it's a maximum, it goes from increasing to decreasing. It crosses the x-axis from above to below, or the second derivative is less than 0 when the first derivative is equal to 0. In addition, when concave up and down has to do with whether the second derivative is positive or negative, or if the first derivative is increasing or decreasing. How many, you could play so many games with how many times I'm going to say derivative and integral today. And also points of inflection are when there's an extrema in the first derivative, or when the second derivative changes signs. I might just start saying like y prime and y prime prime. Okay. So there are some other instances where you might need to justify, including continuity. So I think most of the time you can just kind of assume that it's continuous through the graph. But if there isn't a graph given for some reason, the way that we can justify continuity is by saying that first of all, f of a has to exist. And second of all, the limit as x approaches a of f of x is equal to f of a, and it also exists. So that just basically means that the limit exists and the actual like point also exists. I don't think that's something that comes up very often. I think the last time it came up was like 2008 or 2009. In terms of Riemann sums, these are very, very important for you to know. Remember that when it's a right Riemann sum, if it's a decreasing function, a right Riemann sum is going to be an under approximation. If it's a left Riemann sum, it's going to be an over approximation, and vice versa if it's an increasing function. So this is like a quick quiz. I don't even know. I think y'all should know this fairly easily. Is this a left Riemann sum, a midpoint Riemann sum, or a right Riemann sum, or a trapezoidal Riemann sum? Got a trapezoidal. We got some rights, lefts. Yes, it is a left Riemann sum because, as you can see, it's intersecting from the left point. Yeah, sorry about the colors there. If it was a trapezoidal Riemann sum, it would look like trapezoids. All right, let's look at this one now. Is that a right Riemann sum or a left Riemann sum? Or a trapezoidal Riemann sum? Or a midpoint Riemann sum? How would you know if it was left or right without the rectangles? Well, a Riemann sum diagram has to have rectangles, unless it had trapezoids, unless it was the midpoint. That's how you would know. Usually on free response questions, you will be asked to construct a left or right Riemann sum. And we're going to be doing that in our live practice today. Also, good puns, Rashika. I appreciate it. Okay, so some more instances when to justify include our trapezoidal approximation. So that's what a trapezoidal approximation looks like. Typically, you can kind of estimate concave up or down. So in the instance that it is concave down, usually trapezoids will be under approximations because the second derivative is less than 0. Whereas if it's concave up, trapezoidal approximations tend to be over approximations. Okay, and now we'll go into theorems. I think this part is, the stuff that we learn in the beginning of the year in calculus, and we kind of just forget, or we kind of get them all confused. What about trapezoidal sums and inflection points? I don't know what you're specifically referring to. I would just say that what I was talking about earlier is that if it's concave up or down, that's going to decide whether or not it's an over or under approximation. So if it's concave down with a trapezoidal sum, it's going to be an under approximation because, as you can see here, there's like a little gap here, an area that it's not covering. Whereas if it was concave up, it would be an over approximation because the line would be like this. I don't know if you can see my cursor, but it would be over. All right, let's get into IVT, EVT, rolls, and MVT. This stuff is a lot of fun. Can concavity justify LRS and RRS? I don't think so. Maybe my memory is going crazy from when I took the exam last year, but I think usually it's the other way. I wouldn't say a Riemann sum can justify concavity or vice versa. I think what you would usually do is you would take Riemann sums are purely for approximations, right? And so usually when we're justifying okay, can concavity I understand what you're saying. Are there like over and under estimates with the second derivative? I think it applies the same way. Maybe correct me if I'm wrong, but I think it has to do almost the exact same with increasing and decreasing. So back to this slide here, like if this was concave down per se, well, actually the answer to your question, yeah, it's only with increasing and decreasing because remember concave up or down has portions technically where some of it is increasing and some of it is decreasing. So no, you couldn't necessarily approximate. Yeah. Thank you for answering in the chat. I really appreciate it. Okay. So let's start out with intermediate value theorem. So IVT is something that's tested maybe once every 5 or so years. Or I think it actually applies for all these questions. But basically all the intermediate value theorem says is that if f of x is continuous on that interval between a and b, there's going to be some value where x equals c and then f of c is equal to k. So all that means is that let's say we have point A here and we have point B here on this diagram right over here. Oh, I think I can turn on like a laser pointer. Let me do that. Haha. Okay. So let's say we have point A here and point B here. So basically it says if A is continuous, if f of x is continuous between a and b, there's going to be some value c in between a and b. And at that value c, if we plug in f of c, we're going to get a value k. I know different teachers use different letters. Some people don't use c, some people don't use k. Just use whatever you've been taught in your classroom. I know, right? Cool. I saw it from, I think the bio cram teacher, Caroline. I can't say her last name. I think she's credit to her. With extreme value theorem, it just says that if f of x is continuous on a closed interval between a and b, then f of x is going to attain a maximum and a minimum. And so that's kind of self-explanatory, right? If we go from this is a good example where we'd see a max and a min. But even on this diagram, it's continuous between A and B. So here would be the min and here would be the max. So extreme value theorem just says that as long as you are continuous, you'll see an absolute max and an absolute min. Anyone have any questions? It's pretty self-explanatory stuff. The difficult part on the AP exam is writing this out. Like you need to kind of, I guess now that the AP exam is open book, it's probably good to write this down somewhere, and then you can write it on the actual exam if they happen to ask you about a theorem. Pro tip, but I'm sure you all have taken notes and already know your own kind of template, so I don't think I need to give you one. All right, let's go over the two more convoluted ones, the ones that get people kind of confused. Mean value theorem and Rolle's theorem. Yeah, so we'll start off with mean value theorem here. So the difference between MVT and Rolle's from IVT and EVT is that there's another requirement, and I bolded it here. It's that it has to be differentiable. And that's really, really important, because if it's not differentiable, then unfortunately, we're not going to see the mean value theorem, or the Rolle's theorem actually prove true. So basically, all MVT says is that if we have some, like if we go from A to B, it basically says that there's going to be some value C, where at that point C, it's going to have a tangent line or a slope at that point that is the same as a secant line here. And so it basically says that to find the first derivative of C right here, you just find the change in B, change in Y over change in X. So we practiced this earlier in the 2017 FRQ review stream, or actually I put it at the end of the replay, but that's a good example in which we would be using MVT. All right. And then when we talk about Rolle's theorem, it's just an application of MVT. It says that if f of x is continuous and differentiable, and at some point in time, f of a, so when there's a function and there are two equal y values, then it had to go up and down or down and up. So there has to be some value c where the first derivative is 0, where the slope is 0. So Rolle's theorem is just an application of MVT. It's a good way to remember MVT, actually. Because if you think about it, if we do change in y over change in x for f of b minus f of a over b minus a, you're going to get 0. And so the slope is 0. So this very important stuff for you to know. Does anyone have any questions or want me to re-explain or clarify? Will these slides be available? Yes. They should already be attached to this live review. And yeah, Rolle's is a subset of MVT. Great question. I don't know if Rolle's theorem comes up often. I've only seen it on like tests, like multiple choice, but it's something I think for me at least, Rolle's is a good way for me to remember MVT, because I know f of x has to be continuous on the closed interval, differentiable on the open interval, and therefore there has to be some value c where we do that f prime of c equals change in y over change in x. It's a good way for me to remember change in y over change in x, but just memorize the way you've been memorizing. Okay, so there are some other things to keep in mind whenever you justify. The first thing you need to know is that you need to be very specific on the AP Calculus exam. You can't say it's increasing because it's positive. You need to use f of x, g of x, f prime of x, the first derivative, the second derivative, dy dx, d over dx, etc., etc. Don't say things like the graph or the derivative. Just be very specific. Like, talk about a point on the graph. Talk about the derivative at some point, or f prime of x, etc., etc. Make sure you answer the question, yes or no. And also, I think being concise is also smart. You don't want to write so much to the point where you write out an incorrect explanation. I'd say that 1 to 2 sentences is probably enough for most FRQs. And yeah, thanks for letting me know that the advice is great. Glad to hear that. Okay. So now, what's next? I know it says that it's going to take 40 minutes. I don't think it'll take that long. Maybe it will, but we're going to work on certain parts of the FRQs, and then I'll have you do 3 FRQs to simulate the AP exam, although it's only 2. This was made in like early March. Okay, now I'm going to give you some options here. So would y'all rather just do these FRQs on your own and then have me grade them, or have me work out a few FRQs and then have you submit them on your own? It's up to you. Okay, together on our own. Okay, I see some different responses. Okay, I think I'm going to go with the compromise answer and do a little bit of both. And by the way, if you were here 2 weeks ago, these should look kind of familiar because we worked on these previously. So 1, 2A, and B. So we're going to start off with a practice in and out question. So basically, it just says that the rate at which vehicles cross a bridge is modeled by the differential function r for 0 less than or equal to t less than or equal to 12, where r of t is basically measured in vehicles per hour and t is the number of hours since 7 a.m. So it says that values of r of t for selected values of t are given in the table below. So it says to approximate r prime of 5. So we know that 5 is right here. So here's my first question, and I would answer here in, oh yeah, this comes from the course and exam description. That's where it came from. I want y'all to answer in the chat, in Fiveable or Crowdcast or whatever you're using. What is a derivative fundamentally? What would we be doing? The word I'm thinking of starts with an S. Slope. Yeah, slope of the tangent line. There we go, guys. Great audience participation. I love it. So, or rate of change. Yes, exactly right. So how would we try and approximate r prime of 5? What would we do? I'm not even going to work most of these out. I'm just going to have y'all kind of answer them for me. We're not using MVT here. Close. Yes, average change between 6 and 4. So we would just do, basically, what College Board would ask you for is r of 6 minus r of 4 all over 6 minus 4. So that's pretty much it. And so then we would get something along the lines of, and yeah, I think this question is, we can simulate the actual exam and y'all can use your calculator if you want to. I don't think you would technically need to. You could do this out by hand. What would we get after doing r of 6 minus r of 4 over 6 minus 4? Negative 216. Okay, but what I did with all of these FRQs is all of them make you explain or justify. So here it says, using correct units, explain the meaning of r prime of 5 in the context of the problem. So I want y'all to write out what you would interpret, and then I will type out what I would interpret here on your pod. So write an interpretation of negative 216 in the chat, and we'll go over them. Okay, we got an answer here. At time t equals 5 hours, the rate at which vehicles cross a bridge is decreasing at a rate of approximately 216 vehicles per hour per hour. At 5 hours, the rate at which vehicles per hour cross, I went from saying derivative 20 times to hour 20 times. The rate at which vehicles, okay, Pearl, finish your answer. Derivative is the rate at how many vehicles per hour cross a bridge at time t equals 5. So the answer that I would give here is pretty much exactly what Morgan gave, I think. At time t equals 5 hours, the rate at which vehicles cross the bridge is decreasing at a rate of approximately 216 vehicles per hour, or per hour squared, as Akshita gave there. Do we need to say decreasing to get credit? Yes, because remember the rate, you can't, I mean, I guess you could say the rate is negative 216, but I think decreasing is what they want you to see, because if the first derivative is negative, it is decreasing. So I would say, actually, yes, say that it's decreasing to get credit. Or you can put changes at negative 216. I think arguably you could, but I would say just to be safe, whenever you're writing sentences out, I would use decreasing when the first derivative is less than 0, increasing if the first derivative is greater than 0. Yeah. Alrighty, great job with y'all's interpretations. Pretty much spot on. Let's do part 2A. So once again, we're doing this together, so no need to submit on your pod. This is a classic graph of the derivative FRQ question. And as I said earlier at 4 o'clock, if you need more help with these kinds of questions, which might show up again, I would highly recommend you go to next week's stream at this time slot. So April 27th, 9 p.m. Eastern, mark your calendar, and you can practice graph of a derivative FRQ. So how do you do this with integrals? Okay, great question. Well, let's get into it. So what this question says is the figure above shows the graph of f prime, the derivative of a twice differentiable function, f, on the closed interval 0 to 4. It says the areas of the regions bounded by the graph of f prime and the x-axis on the intervals 0 to 1, 1 to 2, 2 to 3, 3 to 4 are 2, 6, 10, and 14 respectively. So they're very nice here. They gave you the integrals. They told you what was under the curve. So it says the graph of f prime has horizontal tangents at 0.6, 1.6, 2.5, and 3.5, and it's known that f of 2 is equal to 5. So on what open intervals contained in 0 to 4 is the graph of f decreasing and concave down? So when is it decreasing and when is it concave down? And also give a justification, and we'll go over it. Okay, but they also wanted us to give intervals too, Rashika. So here's where answering what they asked for also comes into play, because I think you would get a point here from just explaining the justification. Okay, I have 1 to 1.5 and 3 to 3.5. It says there 1 to 1.6, yeah. Okay, so I see 1 to 1.6, 3 to 3.5. Some of y'all are using parentheses. Some of y'all are using brackets. Okay, and I want to see it. Give a reason for your answer. Yeah, so we're very close on some of these answers here. So what you would want to say is that you're correct that it's 1 to 1.6 and 3 to 3.5. In this instance, they would be an open interval. It would not include 1 or 1.6 or 3 or 3.5. And that's because at those specific instances, the horizontal tangent is 0. So it's neither increasing nor decreasing, neither concave up nor concave down. So I would say something along the lines of the graph of f is decreasing and concave down at 1 to 1.6, 3 to 3.5, because f prime is decreasing and negative on these intervals. Or you could say, f prime is below the x-axis and decreasing on these intervals. So I see some other answers here. F prime is both decreasing. Okay, I get confused between concave down or up. I'll get to that in just a second. Let me read through a few of these. So, okay. So Perla here said at the intervals, the derivative and the second derivative are negative. That one would be a little iffy in terms, maybe you would get 1 out of 2 points. And the reason for that is because the second derivative technically isn't on that graph. So you would have to say that the first derivative is negative and decreasing, because the second derivative isn't on that graph. So you can't really say the second derivative is negative. And yes, there we go. F prime is negative and below the x-axis. That would work. And does AP have a preference? For example, concave down because second derivative less than 0 and because f prime is decreasing. I would say, Rashika, that in this instance, when they give us just the graph of f prime, it's best to say something like f prime is decreasing and negative, and that would get you credit. Graph of f is decreasing where f prime is below the x-axis or negative. In those intervals, it would be, yeah, that works, Akshita. F is both concave down and decreasing in 1 to 1.6, 3 to 3.5, because f prime is both decreasing and negative. Yep. The intervals 1 to 1.6, 3 to 3.5. The graph is f prime and it's below the x-axis on the intervals, showing that the graph of f is decreasing. When the slope of f prime is decreasing, it means f second derivative is negative, making it concave down. Maria, I think in this instance, I think you would still get credit, but I think you can make it a lot more, you can make it concise and kind of just, it would just, in the AP reader, it's just a lot easier to digest. So you could say, you could literally just say the intervals 1 to 1.6, 3 to 3.5 are decreasing and concave down on those intervals because f prime is negative and decreasing. And then you're done. You don't have to you don't have to explain that below the x-axis, or I guess you could, but you don't have to necessarily say that below the x-axis, f prime is negative and slope of f prime is decreasing, makes it concave down. Could you say the slope of f prime is negative? Arguably, yes, I would say. I don't know why you wouldn't, but I don't think you would have to. You can just say f prime is decreasing and that would work. It would get you points. I meant to say graph of f prime, Akshita. Yeah, I see in this instance, adding the words the graph of f is not necessary. You can simply just say, I changed my mind here. you should say the graph of f is decreasing because that's what they ask. But it is the graph of f, not the graph of f prime, because look at the question. It says, is the graph of f prime, it says in small font, is the graph of f both decreasing and concave down? We're not talking about f prime. So you were actually originally right. And in terms of concave down or up, I think Perla's answer, Anika, is pretty good, that drawing it out helps. But also, just if you look at the first derivative graph, remember the second derivative is just whether the slope of the first derivative is decreasing or increasing. So sadly, I don't have a pointer, but if we use the highlighter button here, this should work. Right here, it's increasing. So the second derivative is positive. Here it's decreasing. So the second derivative is negative. Here it's increasing. So the second derivative is positive, et cetera, et cetera. Does that make sense? So kind of putting it in your, and that works too. Concave up is happy face, concave down is sad face. But in this instance, this is a graph of f prime. So that's not how we would evaluate concave up or down. Be very careful about that. Because remember, concave up or down looks different on a first derivative graph and a regular graph. Okay, let's do the next part of the practice, which we'll be doing together. So now we have this graph and ask for us the absolute minimum value for f on the interval from 0 to 4. So for absolute minimum, what do we have to test? What's important? We have to find where the first derivative is equal to 0, but also what? Endpoints, critical and endpoints. I should make that a song. Yes, endpoints is the correct answer. Great job, guys. So I like to make charts. Charts work the best for me, but some people don't do. It's up to you, but you have to know that the graph of f prime, and also remember if it's a minimum, because it specifies the absolute minimum in this instance with the graph, I would only look at when it goes from positive to negative. And so at what points in the interval between 0 and 4 does it do that? Does it go from, or sorry, we're talking minimum here, from negative to positive. When does it go from negative to positive? Thank you for correcting me, Akshita. Whole mess today. When does it go from negative to positive? At what value? 2. Yes, great job. So then we would look at 0, 2, and 4. And actually, in this instance, maybe I wouldn't do a chart just because, I mean, I could. It'd be useful to plug in information for. So I'm just going to write x and f of x. I'm using my cursor now, so this should be fun. So we have 0, 2, and 4. They do give us that f of 2 is equal to 5, but they don't give us f of 0 or f of 4. So we would use, what would we use in order to find 0 and 4? What would we have to use? My teacher does a candidates list and number line. Then keep doing what you've been doing. Go for it. Just do what you're most comfortable with. I like to do like the integrals written out and a table, but honestly, if it gets you the right answer, it doesn't really matter at the end of the day. So then how would we find f of 0? What would we have to do? We would have to use something. Yep, area under curve, and they give that to us, right? But we would also have to use, I'm looking for 2 words. The first one starts with an I. It's not technically that, but it's what I referenced earlier. Initial condition, yeah. It's not technically initial since it's, I guess, in the middle. I don't know. But you would have to use that f of 2 in order to find that integral. So we would do something like, for f of 0, it would look something like f of 2 plus the integral of the first derivative from 2 to 0 prime of x. And so then what would we do next to evaluate it? We wouldn't want to add from the integral from 2 to 0. So then we would flip, and what would it turn into? Subtracting from the integral from what values? From what to what? Yeah, from 0 to 2. Because it's 2 to 0 right now, positive, but when we make it negative, when you subtract, then it becomes 0 to 2. And so I see you answered -8 there. I would be careful about that because the integral from 0 to 2, as given in the question, from 0 to 1 is 2, and from 1 to 2 is 6. So it would actually be, oh wait, it would be f of 2 minus 8, and f of 2 in this instance is 5. So 5 minus 8 Is it an f of 2 minus f of 0 once you flip it? No, we're flipping the integral of, whoops, we're flipping this integral right here. So we're changing it from plus the integral from 2 to 0 to subtracting from the integral of 0 to 2. And so then they give us that the integral from 0 to 2 here is, the integral from 0 to 1 is 2, and the integral from 1 to 2 is 6. So we know that this is equal to 8. And so once we do f of 2, which is 5 minus 8, I did my math wrong. It's 2 minus 6, right? Sorry. I'm confused. Okay. Let me write this out a little bit better. Sorry about that. So we have f of 0 is equal to the the integral from 2 to 0 of f prime of x dx. So what we would do next, oh, okay, yeah. So then what I would do next is f of 2 minus the integral from 0 to 2 of f prime of x dx. And so then what they tell us is 0 to 1 right here is 2, and 1 to 2 here is technically negative 6. So we would do 2 minus 6. And so then we would get f of 2 is 5. And so then we are subtracting negative 4. And so then we get that f of 0 is equal to 9. Whoops, did not mean to do that. All right, why do you have to use the initial condition? Because there's no other way for us to find f of 0. We have to use f of 2 kind of as a starting point and then find the integral. And then we have to add the initial condition to the integral, or subtract technically from the integral to get the point. Why isn't it negative 8? How did you get that? Because the integral from 0 to 2 is 2 and negative 6. Because see, we have to do 2 minus 6. Or 2 plus negative 6 to get negative 4. And so then we do 5 minus negative 4 to get positive 9. Does that make a little bit more sense? If y'all need clarification, tell me which part you want clarification on. If it's this setup part, it's a little difficult. I get it. Okay. All right. Why is it not negative 9? You know, I actually thought that was the answer just a second ago. The reason why it's not negative 9 is because the 5 is positive here. So we know that f of 2 is 5. And we know that the integral from 0 to 2 is negative 4. So 5 minus negative 4 would give us positive 9, not negative 9. Okay, let's go over the setup again then. So we'll start from the beginning. So we're trying to find f of 0. And so f of 0, the way we get that is by putting it equal to the initial condition of f of 2 plus the integral from 2 from here to 0. And so I don't like going in this direction. I like going in this direction. So what I do is I flip it. So it becomes f of 2 minus the integral from 0 to 2 of the first derivative dx, f prime of x dx. And so then the first thing I know is that f of 2 is 5. And so then I need to calculate the integral from 0 to 2 of the first derivative. And so then, and yeah, I got negative 3 earlier actually. And I'll show you why that's not the correct answer. So and this is a tricky question, right? So from 0 to 1, we know that the area is 2. And we know that the area from 1 to 2 is 6. But here we would subtract. We would do 2 minus 6, not 2 plus 6. And that's because we don't, this is a negative area technically. So it's technically like 2 plus negative 6 or 2 minus 6. And so then we get negative 4. And so then we get 5 minus negative 4, and we get positive 9. And so that's how we would get 0 is 9. Does that make a little bit more sense, everyone? How do you know when to make the area under the curve? Just know that if it's under the x-axis, it's going to be, you're adding a negative. Yeah. And sorry if that was confusing there. Yes, it's not 2 plus 6, it's 2 minus 6. Kind of a troll. Okay, I want y'all to do on your own paper f of 4. Okay, we got 1 so far. Yeah, I won't delay it too long. It's 1. And so the way we got that is f of 2 plus the integral from 2 to 4 of f prime of x. And so then you get 5 plus 10 minus 14 equal to 1. So when is the minimum? Okay, I'm still confused about what we need to calculate. So Nico, what we're doing is we are looking at the endpoints and we are finding the f values. So right now we're calculating, yeah, f of 4. So what we did is we looked where the first derivative went from negative to positive, and that was at x equals 2. And then we're looking for f of x. So we're plugging in these x values into, we're finding the integral of the f prime and finding the values of the function itself. So we're finding f of 0, f of 2, f of 4. And the way we're doing that is we're using the integral and the initial condition to find those values. So for f of 4, for instance, that would equal f of 2, which is given, plus the integral from 2 to 4 of f prime of x dx. All right, we see here the absolute minimum value of f on the closed interval is at x equals 4 for the value of 1. I think showing your work for the integrals would be enough justification. As long as you say, I would be, the only thing I would add is what is the closed interval? On the closed interval 0, 4 is at x equals 4 for the value of 1. That's a good justification, Akshita. I'm also going to cut whatever I'd planned for the FRQ. I'm going to cut it a little short because we know that it's 2 FRQs and not 3. So I'm going to look through it. Bonus answer there. I like that. Since f of x is continuous on the interval 0 to 4, the EVT guarantees an absolute minimum value. The absolute minimum value of f on 0 to 4 is 1. Yeah. Maybe I would add the absolute minimum value of f is f of 4 equals 1. That way you're giving like the 4, 1. No, I don't think you need to use EVT to justify, but that's a good example in which EVT should and could be used to justify. Great job, Morgan. Right. Absolute minimum value of 1 occurs at x equals 4 for the closed interval 0, 4 because it's less than the value at both endpoints, and f prime at x equals 4 to 0. I would say that works too. Arguably, you can like write out above your integral calculations, the graph of f prime changes from negative to positive at x equals 2, and then that way you wouldn't have to put it in your final answer. Okay, cool. I'm going to switch back to teacher view here. And we're going to get into some practice where y'all answer some old FRQs on your own. I see y'all took some notes. Good job here. Toiletpaper.exe. Okay, cool. I'm going to keep it short actually for today. Would y'all rather me do you need EVT in our justification? I don't think so. I think it's good to include, but and I think College Board's official scoring rubrics, you didn't have to justify using EVT. Okay, would y'all rather spend the time to do a in and out question or a graph of a derivative question? What is your preference? See, graph. It looks like the overwhelming majority of y'all want graph. Callie, if you want to review in and out, I would highly recommend you check out the replays of our last 2 FRQ streams. Those should be located at app.fiveable.me/AP Calc. We went over in and out questions the last 3 weeks, and we'll be doing those also at 4 p.m. Eastern. I always do one for AB students at the beginning. Okay, so let's do some graph questions, graph of a derivative. So we'll start off here on part 2. There's going to be a timer here. It's kind of rough, but I really want y'all to be kind of in the mindset that we need to be working on these questions at a pretty quick speed. So good luck. And make sure you're justifying. That's what today's stream is about. Alrighty, let's review some responses. Let's hide student names. Okay, so here we see that at x equals 10, g is neither because the graph stays negative. So remember, this question asks, does g have a relative minimum, maximum, or neither at x equals 10? So what we would need to justify here has to be more than the graph stays negative. I would say something along the lines of, because g prime of x is equal to f of x, and f of x is less than 0 for 8 less than x less than 12, because we're talking about between 8 and 12, the f of x is less than or equal to 0, and that's the first derivative. All right, let's keep going. At x equals 10, the function g, oof, that's okay. We run out of time all the time. G prime of x is equal to f of x. G prime of 10 equals f of 10 equals 0. Doesn't change signs. G has neither a relative minimum nor maximum, since g prime of x equals to f of x does not change signs at x equals 10. Yeah, I think something I would add to this is something I would add on top of this would just be that f of x, or g prime of x, is less than or equal to 0 for 8 less than x less from the interval from 8 to 12. And that way you can justify that it doesn't ever go positive. It just stays negative. F does not go from negative to positive or vice versa. And under the second fundamental theorem of calculus, f of x is derivative of g of x. By the way, for those of you who put g prime of x is equal to f of x, you would automatically get 1 point. And you get a second point if you justify by saying that f of x is less than 0 in the interval from 8 to 12. And for those of you who are saying you really like this interactive format, I'll definitely pilot it. Do you all want to see this in the FRQ reviews in the afternoon? If that's something that you want, then I'll do it. Yes, yes, yes. 3 exclamation marks. Okay. Yes, yes, yes. Oh my God. So much positive feedback today. Okay, then we'll definitely incorporate them. Okay, I meant that g has neither a local max or yeah, Nikki, that I think that still works. F of x stays negative to the left of 10 and to the right of 10. Yeah, that works. Okay, let's keep going. G of x has neither relative max or min at x equals 10 because g prime of x, which is f of x, so that's 1 point, does not change signs. Still works. I think just including a part about how, the surround from 8 to 12 is entirely negative or something like that, that would do it justice. All right. G has a relative maximum at x equals 10. All right. So here, remember, this is a graph of f, not a graph of f prime. So they try and trick you sometimes with this. And so therefore, remember, we'd be talking about how because the entirety of the graph of f, or sorry, confusing myself here, the graph of g prime is the graph of x. So when we look at the function g as a whole, there's no min nor max because the first derivative never changes signs. It stays entirely negative from 8 to 12. All right, it's 10, the graph is 0. And in order for it to be relative minimum or maximum, it has to change sign. Good job. Right, and I think, yeah, these are blank. That's okay. Cool. Okay, let's do the next part. Part 2b. Same 3-minute timer. Good luck. I forgot if sharp turns affect this or not. Ooh. Alrighty, let's look at this. So, we're talking about points of inflection here. So, first thing I would always add is g prime of x is equal to f of x. Good job here. The inflection point is where graph changes concavity, okay? And so then at x is less than 4, the graph of g is increasing, and then at x greater than 4, the graph of g is decreasing. So it has an inflection point at x equals 4. So I would be very careful here. I think you might get lucky with points here, but in this instance, you'd want to say something along the lines of f of x, or the graph of, I might be misinterpreting this. The graph of g has a point of inflection at x equals 4 because g prime of x is equal to f of x. On the f of x graph, it's increasing from 2 to 4, and it's decreasing from 4 to 8. And so in this instance, when you say the graph of g is increasing, in this instance, I think you should be talking about the graph of f. But I don't think that would take off too many points for that. At x equals 4, the graph of g, oh, here we go again. See, got to be very careful here. It's the graph of f. And so in this instance, sharp turns, I don't think would affect the point of inflection because, oh, sorry, wait, you're right. The graph of G has a point of inflection because the slope of F, which is G prime, is positive to the left and negative to the right. I think instead of left and right, you would want to kind of specify the interval. So 2 to 4 or less than 4, greater than 4, something like that. That'd probably help you out there. G has a point of inflection at x equals 4 since G prime of x equals f of x changes from increasing to decreasing. I would add here that it changes from increasing for this interval and decreasing for this interval. Okay, cool. Yes, because G prime of x is equal to f of x, and at x equals 4, there's a change in concavity since f of x goes from increasing to decreasing. Yep, which means there's a point of inflection. G is a point of inflection x equals 4 because its derivative, f of x, yep, changes from increasing to decreasing. Graph of G does not have a point of inflection. It's not differentiable due to a sharp turn. Okay, so sharp turns, I guess let's talk about this, right? So, y'all fell for it here. It says the graph, did I not put it on here? Maybe this is my fault, but I think it did say that the function was twice differentiable, but I guess not. So in this instance, they give us the graph of f, and we know that basically the first derivative of g is the graph of f. So at that point, it is differentiable. Yeah, I get that. I feel that. It is differentiable at the value of 4. And that's because whenever we think about whether something is differentiable, it has to do with the definition of the derivative, right? So as the limit, as we go from here to here. That's a good point. I think it's still, it goes from increasing to decreasing. And so at that point, it is differentiable. Let me think about it. I will definitely get back to you after. Wait, this is a first derivative. Inflection points are where the second derivative equals 0. Is this the graph of f? This is the graph of the first derivative per se. It's technically a graph of f, which is g prime. So yeah, that stupid me. My brain at 9 o'clock is going haywire, and for 10 o'clock for Eastern folk, I'm so sorry. Yeah, so because it's a graph of the first derivative, inflection points are where the second derivative equals 0. Okay, I had some more stuff. I had like an extra part, but I don't think we have time for it. I've already gone over time. I want to be respectful of your time. So I am going to show y'all. Wait, let me see if I can share it. Is that a thing I can do? This is cool. Yeah, so I used a bunch of these resources in today's live review. I highly recommend you check all of them out. The slides are linked below here in the resources section. And yeah, check out Fiveable social media, TikTok, Twitter, Instagram, YouTube. Make sure you check out our different weekly streams, and these are the upcoming live reviews. I have a question though, for those of you, can you give a final answer for part B? Emmeline, my answer would have been the graph of G as a point of inflection at x equals 4, since G prime of x is equal to f of x, which is increasing for 2 less than x less than 4, and decreasing for 4 less than x less than 8. So I would say that it's decreasing from this interval and increasing from this interval, if that makes sense. Okay, it does make sense. Sounds good. So you look at the change of the integrals. Anika, are you talking about the last question? That one, we were talking about derivatives there. So all we were talking about is whether there was a point of inflection of the graph of G. And in this case, the graph of F was the graph of G prime. And so we saw that it was increasing and then decreasing. So it had a point of inflection at that point. So we were not looking at integrals, we're looking at derivatives. Yeah, okay. Well, yeah, I'll probably do like split half and half, and that's how it'll work. Well, thanks everybody for spending an hour and 5 minutes with me today. And in fact, if you were at my earlier calculus stream, that means we spent 2 hours together of our day doing calc. But you know, I really want to help y'all succeed and get 5s on these 45-minute online free response exams. So thanks for coming, everybody. Definitely check out next week's streams. Be here at 4 o'clock and 9 o'clock, and we'll help you out with your calculus questions. Thanks so much. I'll definitely be using Nearpod for like almost all of my streams for calculus in the future, since y'all love it so much. And yeah, see ya.